Hi everyone. In this video, let's solve Leetcode problem number 1, to sum. So the problem states that given an array of integers and an integer, return the indices of two numbers such that they add up to the target. So let's look at some of the examples and try to understand this problem. Let's take this example where the input array has 4 elements, 2, 7, 11 and 15. And the first row here is the corresponding indices of each element. And let's also say the target is 9. Now we need to find two numbers and return the corresponding indices such that the two numbers add up to the target. Looking at the elements of this array, we see that the numbers 2 and 7 add to 9, and hence the answer for this example would be 0, 1. It is also mentioned in the problem that we can return the answer in any order, so we can even return 1, 0. Let's look at one more example. Let's take this array where we have 3, 2 and 4 as the elements of the array, and let's also say the target is 6. Now looking at the input array, we know that 2 and 4 add to 6. Note that we can also look at 3 and add it to itself to get 6, but it is mentioned in the problem that we may not use the same element twice. So using 3 twice to get to 6 is not allowed. And hence the only solution here is 2 plus 4 equals 6. And hence the answer would be the corresponding indices, which is 1, 2. Let's take one more example. Let's consider this array which has two elements, 3, 3. And let's say the target is 6. Now we know that 3 plus 3 equals 6. And hence the answer here is going to be 0, 1 or 1, 0. Now let's discuss about how to solve this problem using a two-pointer approach. Let's take this example where our input elements are 2, 7, 11, 8, 3 and 15. And let's say the target is 15. Now just looking at the input elements of the array, we know that 7 and 8 added together gives us 15. And hence we know that the answer for this problem is going to be 1, 3. Now how do we solve this? We basically use two pointers, and we are just going to find the sum of all combinations until we reach the target. And once we reach the target, we just return the indices of the two elements. So we start with the first two elements, 2 and 7. This is not going to add to 15, so we just keep the left pointer as it is. We just slide the right pointer to the next element. Again, 2 plus 11 is not the target, so we continue with moving our right pointer. And this combination also doesn't add to 15, so we continue with moving the right pointer again. And similarly here it is not 15, so we move to the next. And once we reach the end of the element, we're just going to adjust the left pointer to the next element. We just completed all the combination that has 2 as one of the elements, and we did not find the target. So we are done with 2 at this point, so we're just going to move the left pointer to the next element and repeat the same. So here 7 plus 11 is not 15, so we move the right pointer, and finally we reach a target 15 by adding 7 and 8, and the answer in this case would be 1, 3. Now what is the time complexity of this problem? We are just going to use two pointers, which translates to two nested for loops, and we're just going to iterate over all the elements, and hence the time complexity of this solution is big O of n square, and the space complexity of this solution is big O of 1. Now let's see how to implement this. We are going to have two for loops, one for the left pointer, which is going to run from 0 till the last element. We are going to have two for loops, one for the left pointer, which is going to run from the first index till we reach the last element of the array. And the inner for loop is always going to start from a position that is immediately next to our left pointer. So in this case, the right pointer will always start from I plus 1. And it will continue till we reach the last element of this array. And once inside the for loops, we're just going to check if these two numbers add up to the target. if they add up to the target, we're just going to return a new array of size 2 that will hold the indices of these two numbers. So in this case, it is going to be I comma j. This can be j comma I also. As per the problem statement, we can return the answer in any order. So this can be j comma I also. And outside these two for loops, we are just going to return null. Note that this null statement will not be reached at all, because the problem statement clearly says that there is going to be exactly one solution. So there will be one combination of nums of I and nums of j that will add to the target. The return null is just added so that we don't run into any compilation error, because a function needs to have a return statement as long as it is not a void type. Now let's run this code and see if the test cases pass. As you can see, the test cases passed. Now let's submit the code and see if the solution is accepted. As you can see, the solution is accepted. Let's look at the description of this problem. Towards the end of the problem and the examples, there is a follow-up question to this where it says, can you come up with an algorithm that is less than big O of n square time complexity? So we're going to discuss a linear solution to this problem, which will use just one for loop instead of two for loops. Let's take the same example. The input array is having 6 elements, 2, 7, 11, 8, 3, and 15, and the target is 15. Now we are going to find two numbers such that they add up to the target value of 15 by using only one pointer. And this pointer is always going to start from the first element. Now let's think about how to find two numbers using just one pointer. At any point, once we know the value of the current pointer, we need to have a way to find if the target minus the current value is present in the array. Now, how do we do it? We just cache everything as and when we visit a particular element. And then when we visit another element, we just check if our cache contains target minus our current number. So for example, in this case, this is our first element that we are visiting from the input array. So we won't have anything in the cache. Our cache is basically empty. So what we do, we just add the current value along with the index to our cache. Now we need to add the index to the cache because as per the problem statement, we need to return the indices of the two numbers, not the two numbers. So we need to have a way to tell, okay, the value of 2 was present in index 0. That way, later in the array, if there was an element 13, we would know that, okay, we already visited 2 at index position 0 and 13 at whatever position. So we just return those two indices as the final answer. Now we just move on to the next number, which is 7. And we check the cache if we visited 15 minus 7. Obviously, we did not visit 8. So what we do, we add 7 to our cache along with its index. So we add 7 with an index position of 1. And then we move our pointer to the next element, which is 11. And we check in our cache, did we visit 15 minus 11, which is 4. But we did not visit a 4 before we reached 11. So we just add 11 and the corresponding index to our cache, and then we move on. Now, once we are at 8, we check if our cache contains 15 minus 8, which is a 7. And we know that we visited 7 at index position 1. Once we find a number in our cache such that that number added to the current number equals to the target, we return the corresponding index position in the cache and whatever the current index is. So in this case, the answer is going to be 1, 3. And because we use just one pointer to iterate from the first element to the last element, the time complexity here is going to be big O of n. But what is the space complexity? Unlike the big O of n square solution where we use 2 pointers to find the sum of all combinations. Here we are just using one index, and that justifies the time complexity. But then we need to cache all the elements in a temporary cache, which means at the worst case we need to store n elements, and hence the space complexity is big O of n. In other words, as the size of the array grows, we need more space. Let's think about how to implement this cache structure. If we look at the cache structure, we need a way to tell this value is mapped to a particular index. So this would be more like a key value structure, and we can implement this cache using a dictionary object which has an integer key and an integer value, and the value is going to be the value of the array, or rather the index is going to be the value of the array, and the value of the cache is going to be the corresponding index. This will be clear once we implement this solution. Let me delete the previous code. We don't need this anymore. And let's start with the dictionary structure for our cache. And this dictionary is just going to have integer key and integer value. Let's call this as cache. And for this solution, we are going to have one for loop, which will start from the first index, run through all the elements in the array. Okay. Now, for each element, we are just going to do two things. If the target minus the current number is present in the cache, we are just going to return an answer. If not, we're just going to add it to the cache. If the cache doesn't contain the number already, we should not add duplicate entries into the dictionary. So let's first check if our cache contains, and again we are going to check the contains key because we want to check if the cache contains a key which equals target minus my current number. So if this is present, we know that we identified a combination that adds to the target. So we're just going to return an integer array whose value is going to be whatever value pointed by the cache that has this target minus nums of I as the key, and the current position or the current value of I. And you can change this order again. The problem states that we can return this in any order. Okay, if this is not the case, we want to add the element to the cache only if the cache does not contain the number already. So we are just going to check if the cache does not contain the current key. So that will be nums of I. We are going to add a new entry into the cache, and the key for the new entry is going to be nums of I, and the corresponding value is the index, which is I. And this should be it. So once we are outside this for loop, again we are going to return null. We are returning null, otherwise the code will not compile. Note that we are not going to hit this line at all because there will be one combination which will add to the target. Now let's run this and see if the test cases pass. As you can see, all the 3 test cases passed. Now let's submit the code. As you can see, the code was accepted. Hope this video was useful. Thanks for watching.